Hi, I'm Jake Franklin with Mack McClain and Associates. Today we're here to talk about the Powers digital mixing valve, the Intellistation Jr. So let's start with talking a little bit about the history of mixing valves and thermostatic options for master mixing valves and how that has evolved into digital. So let's take a look.
Okay, let's take a look at the history of mixing valves. So, the first mixing valve was established back in 1911. It was a bimetal coil. So basically, that coil would uncoil and recoil depending on the temperature of water flowing across that mixing valve. And as that coil would uncoil or recoil, it would change that little piston that would affect the ratio of hot and cold into that mixing valve so that it could dial in on its set point. Somewhere around 1919, we moved to a liquid-filled cartridge. Looks very similar to that paraffin-filled cartridge there on the end, only it's just filled with a liquid. And the expansion contraction of that liquid would move that plunger, move the stem, and that stem would affect the ratio of hot and cold into that mixing valve. Then in 2000, that technology moved to a paraffin-filled cartridge, basically a wax-filled cartridge, because the wax expands and contracts quicker than the liquid did. And so the reason for going from bimetal to liquid to paraffin is just basically tighter temperature control. So where you were roughly plus or minus 15 degrees set point with a bimetal, then you were like plus or minus 10 degrees from set point with a liquid filled, and then plus or minus 7 degrees from set point with your paraffin filled cartridge. And that's where thermostatic technology currently sits for thermostatic mixing valves. Okay, so let's talk about thermostatic mixing valves and their performance. So basically, here are some of the fallbacks. You got to have equal pressures across hot and cold inlets. They got to be within 20% differential of one another to be able to appropriately mix and hit set point. So, with a thermostatic mixing valve, you're never going to get it to fully close off hot or fully close off cold. It only closes off about 80% one way or the other. So if you still have an opening on either side, even if you're trying to go full hot or full cold for the set point of that mixing valve, if the pressure differential is too great, then it'll just overcome the other side, hot or cold. It needs to properly be piped to a diagram. That means all the checks in the right spot, the return pump in the right spot, the balancing valve in the right spot, which brings me to the next point. It needs to be properly balanced. So we'll talk more about this, but open loop versus closed loop, or flow versus just recirc. Same thing, open loop, closed loop. Once you're in a no flow situation, just recircing around in that loop, if you went out at 120 degrees and when you got back, there was maybe a 5-degree heat loss and you're at 115, well, most of that return water just needs to go back into the cold side of the mixing valve and back out for the recirc loop. And only a little bit of it needs to go back towards the heater so that it can make up for that heat loss on the loop, that 5 degrees. So very little of it would be going back. If too much of it goes back to the water heater, well, then you're going to get temperature creep. And that mixing valve will try to adjust and say, hey, it's too hot. It'll start to close off the hot inlet. But because it can only close off about 80% one way or the other, then it's still going to be able to allow flow on that side. If too much is being forced back towards the heater by that recirc pump, that's when you're going to get your temperature creeping up overnight when no one's using water and you're in a closed loop situation. So that's where you go and you put in a balancing valve on that return piping there. And so that you choke it down to say maybe 95% closed. So it's only allowing 5% to go through that balancing valve and back to the heater, the other 95% back into the cold inlet of the mixing valve. Maybe that's too much. Maybe it needs to be choked down to 97, 98%. Or maybe it's not enough. Maybe it only needs to be 90% choked down and allow 90% of the return water to go back to the cold inlet and 10% back through the heater to be reheated and make up that heat loss on the loop. So that all needs to be properly balanced and properly piped. Oversizing pumps, not having check valves in the right spot. These are problems that will cause a thermostatic mixing valve to not function properly. And regular maintenance is required. They're susceptible to scale buildup. That's the #1 reason that a thermostatic mixing valve fails, is that it gets scaled up and then it needs to be rebuilt, parts taken out, descaled, and so forth. Minimum flow with thermostatic, okay? So if you have a building that's going to have times of higher demand, but then also times where there might only be 1 or 2 faucets running, typically you're going to have to see, a big mixing valve paired with a small mixing valve. That way, those are separated on the outlet side by a PRV, and you set a pressure there. And so all flow will go through the small mixing valve until there's enough demand downstream that there's a pressure loss. Then that PRV will open and allow flow to go through the large diameter mixing valve as well. So a high-low system with 2 valves in it may be necessary when you're talking about thermostatic master mixing valves. And temperature creep, we talked a little bit about that. That's with that closed loop situation if it's not balanced properly. Those are all kind of drawbacks to having a thermostatic master mixing valve. Okay, sanitization mode. So this is becoming an increased hot button issue, especially with the awareness that has been brought to things like Legionella in a hot water distribution system, and other bacteria, other waterborne pathogens. Hospitals, VA centers, places with people with, immunocompromised patients. Those are more and more often here looking at regular sanitization. Now, whether that's every month, once a year, every other month, twice a year, whatever it might be, basically running a high enough temperature through your entire recirc system and opening faucets and letting it run out, that you're just shock treatment of the system and killing off any bacteria that might be growing in that system by running extremely hot water through it. So in thermostatic, to do so, you're going to first off have to take your adjusting bolt on the mixing valve out to the highest set point. And then, because you can't fully close off the hot or the cold, you're going to have a little bit of cold blend in there. So if you say you wanted to run 160-degree water to sanitize the whole system, you're going to have to turn up the hot water source, the water heater or boiler, to maybe 180, 185 degrees to be able to blend with a little bit of cold and hit that 160-degree set point for sanitization. Probably also have to open your balancing valve wide open so that you're not limiting any water going back that doesn't drain out of the system, comes back on the return loop, all of it back to the heater so that you can keep that temperature high enough to sanitize the system. So once you do all that, then you've got to go back in and reset the whole system, set your balancing valve back where it needs to be, set your water heater back at the temperature you had prior to being in sanitization mode, and then dial back in your mixing valves. So it's a time-consuming and difficult process to do with thermostatic. Okay, so now let's talk a little bit about digital mixing valves. So, tighter temperature control. So where we were plus or minus 7 degrees from set point with the current technology for thermostatic master mixing valves, plus or minus 2 degrees from set point with digital. So tighter temperature control. No inlet pressure constraints. The pressure can be, there can be a much larger differential between hot and cold, and it'll still work on a digital. No balancing required. It's a self-balanced system because the digital mixing valve can close off that hot inlet or that cold inlet basically 100%. And so if the temperature is creeping up overnight because too much water is going back towards the water heater in that closed loop situation, it'll just close off the hot inlet and force all the water to go back into the cold inlet on that return loop until it starts to cool, and then it'll crack back open a little bit. But it's self-balanced, no need for a balancing valve on a digital mixing system. And that in itself controls temperature creep. They're offered in pre-piped, so that makes it a lot easier with the check valves and isolation valves, just basically water in, water out, and then piping up your return. With the pre-pipe systems, they are offered with and without the recirc pump already there. But if you do a less recirc pump and add your own recirc pump, it does need to make sure that that pump is in the proper place per the piping diagram. This slide here says unaffected by water chemistry. That's not 100% true. They are heavily resistant to scale buildup, but not fully. I mean, it certainly would take a lot longer of a time with a digital mixing valve to fail because of scale buildup than it would with a thermostatic option, but they are significantly more resistant. Basically, that's because in that 3-port ball valve on a digital mixing valve, it's a stainless steel ball valve in there. So scale won't build on stainless steel, and the constant motion of that 3-port ball valve kind of is shading that ball valve at all times to try to help prevent scale buildup on it. So significantly less maintenance with it. Time to set it dramatically increased. I mean, once you've got it piped up, you can set that valve in 2 minutes. No minimum flow. I mean, there's a 0.5 minimum, 0.5 gallon per minute minimum flow on digital mixing valves, but it eliminates the need to have a high-low 2-valve system, because even your smallest mixing valve on a high-load thermostatic system, that's going to be down there around 0.5 gallons per minute. So because there is such a low minimum flow rate on digital, no need for a 2-valve system, unless you're talking about, I've got a ton of flow and I've got to have a 2-inch system or a 3-valve 2-inch, all 3 valves 2-inch system that accommodate extremely high flow rates. But no 2-valve system to accommodate the minimum flow rate. They're BAS compatible. That comes standard on the Powers digital mixing valves. No added module or anything like that. They're BAS capable from the jump, which helps with the data monitoring. A bunch more data monitoring points: temperature, pressure, hot, cold, mixed, return. So that data really helps for troubleshooting when there is an issue. Okay, let's move on with the digital mixing valves. The first digital mixing valve the Powers came out with was the Intellistation. So like we said, plus or minus 2 degrees from set point, 0.5 gallon per minimum flow rate, high temp sanitization process. So easy to do a sanitization on a digital mixing valve. You just jump into your programming. That's a touch screen on the controller there. Plug in your password, go into the sanitization mode, tell it what temperature you want to run your sanitization mode throughout the building at. And as long as your water heater source can provide that temperature, and then you set a timer. And so it'll rise the temperature up to say 160 degrees, as long as you're providing 160, 165 degrees from the heater, and then start let's say a 30-minute countdown. And then when that 30-minute countdown stops, it'll go right back to the parameters that you had set beforehand, and bring that temperature back down and go right back into controlling the temperature in that loop. So very easy to do a sanitization mode. The install is super easy, especially on the pre-pipe systems. Gauges for all that monitoring, those come on those pre-pipe systems. And pump control. So as I said, you can order these things with a pump or without a pump, but that pump can be controlled right through the controller on these digital mixing valves. So if you want it to turn off and on, depending on what the temperature is coming back on the return, you can do that. Eliminates the need for an aquastat, but you can always just put it in always on mode too, which is probably the preferential setup, because turning them off and on just shortens the life of the pump. And because this thing is self-balanced, there's really not a need to be turning the pump on and off. But either way, it can be done through the controller, so you don't have to have an aquastat or a separate power source for the pump. This is just a little slide of the Intellistation, offered in 1.5 and 2-inch, and then multi-valve systems. Just got your flow rates and all that there. Okay, the Intellistation Jr. So the Intellistation Jr. was our 2nd generation mixing valve that has come out, digital mixing valve that has come out. It's kind of a boiled down version. Okay, so instead of having temperature and pressure sensors on your hot, cold inlets, your mixed and on your return. This just has a temperature sensor on the mixed outlet. The controller is bolted right there to the actual 3-port balancing valve, but the same actuator as the original Intellistation has. And these are a lot less expensive than the full Intellistation Sr. That was first brought out onto the market by Powers. And there's the spec sheet stats for the Intellistation Jr. While we're talking about the Intellistation Jr., just like the Senior, it is passcode protected. Comes with a default password on it, but that can be changed by the maintenance crew or the building owner. Programmable set range anywhere from 60 degrees Fahrenheit to 180 degrees Fahrenheit. Real-time stamping for error messages. Programmable right there on the touch screen, just like the Intellistation Sr. Mixed outlet temperature can be adjusted or monitored at the valve. You don't need to bring out a computer or a module chip like zip thumb drive like you do on some other brands. It's all right there on the touch screen. Also still BAS capable, comes with that standard, no additional module for tying into a BAS system, and it now has Wi-Fi capabilities. So if you've got a building that doesn't have a building automation system, but wants to be able to monitor their mixing valve, that can be done via Wi-Fi, with an app. It can be, to a computer or to a mobile phone. Okay, so with that, let's head out into the wet lab and take a look at some of these digital mixing valves that are actually in service.
Okay, so here we have the Powers Intellistation Sr. This is the first digital mixing valve that Powers put out. It has the plus or minus from set point rating of 2 degrees versus the thermostatic, which is going to be plus or minus 7 degrees. So a little bit tighter control on the temperature. It has the actuator, a 3-port ball valve, and then a variety of sensors that we'll talk about. So the way this works is that the temperature sensor on your mixed outlet senses that the temperature has risen too high above your set point. It's going to tell that actuator to move the stem on the 3-port ball valve, allow a little bit more cold water in than hot water to bring that temperature back down to set point. It's always kind of adjusting, tick, 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 tick. That digital actuator is in constant motion. So that constant motion moves the stainless steel ball valve that's on the inside of this 3-port valve right here, and that constant motion helps to slow down the buildup of scale, which is the #1 reason that a thermostatic mixing valve fails. So on the Intellistation Sr, we have temperature and pressure sensors on your mixed outlet, your hot inlet, your cold inlet, and on your return piping right here. So there's a ton of data here which really helps to troubleshoot problems. So let's say you've got a facility calling and saying, hey, mixing valve isn't, it's not working, we're running out of hot water, or it's not producing hot enough water in the morning. Well, you might be able to come and take a look at your data on this and see all your sensors, and you can say, oh, hey, well, I see that the low inlet of your hot side had dropped down to 85 degrees. Well, I can't provide 120 to the building if you're only supplying hot at 85 degrees. So that's telling you that you ran out of hot water. So it can help to troubleshoot and diagnose problems in that way. It looks like in this case, your hot water heater is undersized, or it's not enough capacity and it ran out. So those data points can be very beneficial on a job site. As far as setting this thing up, you hit the program button, right? And it's password protected. There's a default password that you can plug in, or this can be changed by the facility to whatever they want. Once you enter the password, you hit enter, accept the danger warning, go to setup, system. Here in the system screen, we have the mixed set out point. Mixed outlet set point. We have a high temp alarm. We have the pump operation, which can be on, off, or auto. We'll talk a little bit more about that. And we've got the pump head that you're going to want to set, and the pump minimum or maximum off time if you are going to have it on auto, to where the controller is turning that pump on and off when it doesn't need to be recirculating water. in my opinion, I would just keep this on auto on. Just turning on and off your pump just usually shortens the life of the pump. And this thing is self-balanced. Okay, and so typically, like we talked about earlier, on a thermostatic setup, when your return water comes back, if you've got a closed loop system, meaning there's no draw on the system, if all the return water went back to the cold inlet, because there's no new water being introduced to the system, if there's no draw on the system, the pipes are completely full of water, there's no way to bring in new water from the street, new cold water. So when it's in that closed loop and water's just recirculating around through the building, basically, let's say it went out at 120, when it got back, let's say it was at 110, so we had 10 degrees of temperature loss. If it just went right back into the valve and back out again, then it would go back out at 110, and we lose another 10 degrees on that loop, come back at 100, and it would keep dropping like that until you hit the ambient temperature of the building. If all that return water went right back to the water heater, then there's no way to push new cold water in to blend with it, so it would just be pushing out the supplied hot water in storage. Let's say at 160 degrees, you would see temperature creep going up until all the water in the return loop was at whatever temperature the water heater is at. So you have to split that. That return water comes back. If it lost 10 degrees, maybe you putting about 90% of it back into the loop at the 110 degrees, and sending 10% of it back to the water heater to push that 160 degrees to blend in with the 110 from the recirc loop and bring you back up to your 120 degree desired outlet temperature. Maybe that percentage is less. Maybe 95% of it needs to go back, and only 5% needs to go back to the water heater to make up that heat loss on the loop. So on a thermostatic mixing valve, which can only really close off its hot inlet or cold inlet about 80% one way or the other, that's not enough. So you have to add a balancing valve to that system that is basically like a teetered ball valve that is choking it down, forcing, say, 95% of it back into the mixing valve and allowing 5% to get through that balancing valve and go back to the heater. So you have to balance it in there, and it's a slow process of setting that system for the closed loop system overnight when no one's drawing water. So that the first thing in the morning, someone opens the first faucet and they don't get scalded. So a digital mixing valve, our digital mixing valve, is able to close off about 99.9% one way or the other. So it does not need a balancing valve. It's self-balanced. So if that water comes back and it's too hot, well then it will just close off its hot inlet, which would then not allow it to travel back towards the heater, but force it all back into the cold mix outlet on this bridge right here. So this system comes on a skid, pre-piped like this. All you have to do is hook up your cold inlet, your cold inlet, your hot inlet, and your return loop right here, and then your mixed outlet going out to the building. So just 4 connections that you need to make. This is already all pre-piped. If you've ordered it without the pump, then this section of the skid right here, this piping will just be a solid piece of pipe. You'll cut in and put in the recirc pump as needed. But that recirc pump needs to be placed just like it is here on the return line before it hits this bridge. It goes back to the cold inlet of the mixing valve. So the self-balance part of it makes it such a much easier setup and much easier install. Easy to keep balanced because it's a self-balanced valve. As long as it's piped correctly and the recirc pump is in the right spot, then you should be good to go. As far as setting this thing, you hit the program, you unlock, put in your password, enter, accept, setup, system, and then you would go to that mix set point, hit enter. There's a touch screen here with a sliding scale that you can just dial it in, or you can use the arrows to change 1 degree at a time. And dial in, in this case I got it at 125, okay, that's set up. You set up your high temp alert, go into high temp, I set it at 125, so let's say I want to set my high temp alert at 140. So I dial that into 140, hit okay. If the outlet temperature was to raise up to 140, this thing would shut down, fail to cold, recalibrate, come back up, try to balance back in. And if it continued to hit that 3 times in a row, that high temp alert, then it would go into a lockout mode, fail to cold, and it would sound an alarm. Someone would have to come down and troubleshoot, figure out what's going wrong with the system. Pump operation, you just go in, hit enter, it's either on, off, or auto. Auto is going to shut the recirc pump down whenever the temperature is pretty much what it went out at. So it doesn't need to recirc water. And once that sensor cools, it'll say, okay, hey, time to kick back on, and you'll set a minimum on and off time for that too if you choose to, or you can just have it off, have it controlled separately by power or by an aquastat, or you can have it just always on run, which is my preferred setup on it. But each case is different. So once you've got all those programmed in, you just go back out, you can go to your home screen. It's going to show you your mix set point and what your actual mix temperature is on the outlet there. You can toggle through these and see your hot supply temp, your cold supply temp, your recirc return temp, your pressure on the mixed outlet, your hot side pressure, your cold side pressure, your recirc pressure. All this data is going to help you diagnose and make sure if you're having an issue with the system that we can diagnose it and then come up with a fix on it. Going back into programming, there's also the sanitization mode. So especially with increased concerns over things like Legionella, a lot of buildings are calling for an annual or semi-annual, maybe quarterly, monthly, depending on the facility and what their concern is, of running hot enough water through the entire system to kill off any bacteria that's growing in it. So if you're on the Powers Intellistation, you just go into your sanitization mode, you select your temperature, enter, and say we want it to do it at 160 degrees as long as I'm supplying the hot side with 160 or better. I can raise it to that temperature, hit OK, go to your time for that sanitization mode, enter, let's say I want to run it for 35 minutes, OK, then I go into mode, right, enter, hit on, and then hit OK. And as soon as I hit OK, it's going to start to raise the temperature of the mixed outlet by moving that actuator and that three-port ball valve to raise that temperature up to whatever I set it at. Once it hits that, it'll start a countdown on there. And once it gets down to the end of the 35 minutes, it'll go right back to the parameters of normal operation. That's a much more difficult thing to do on a thermostatic unit. You basically have to try to raise the temperature to the highest point of the actual mixing valve. Probably going to have to raise your supply temperature significantly above that desired recirc sanitation mode temperature. And you're probably going to have to open your ball valve on the balancing valve wide open. And then once everything is done and you've completed your sanitization mode on thermostatic, then you're going to have to reset the entire valve. Rebalance it, reset your heat source. And so it's a very complicated process with thermostatic, very easy on digital. There's also a monitoring feature here that's going to give you a bunch of data points. So, high temperature of your mixed outlet, high temperature of your hot side, low temperature of your mixed outlet, low temperature of your mixed side, so that you can come in and if there's been problems, you can look through and say, oh, I can see that this rose up to the highest point of this, or the lowest point of this, and that's going to help you diagnose and troubleshoot as well. There's some toolbox in here set up, and then whenever you're ready, you've got everything programmed, it's ready to operate, you can just lock the screen again, hit home screen, and then like I say, so it's showing you right here, I put it into sanitization mode, it's got my timer on there, and it's going to slowly start raising that temperature. So we're going to stop that. Okay, so historically, a digital mixing valve is much more expensive than a thermostatic option. And the reason that a contractor might elect to go to a digital over that thermostatic option is most likely because an engineer hard-spec'd it, because that engineer understands the benefits that come along with digital over thermostatic. But the cost difference was huge. In more recent times, there are models of the digital mixing valve, like the Powers Intellistation Jr, that is a much more cost-comparable option compared to thermostatic. Let's go take a look at the Intellistation Jr. So here we have the Intellistation Jr. The thing is very similar to the Intellistation Sr, only instead of having a temperature and pressure sensor on your mixed outlet, your cold inlet, and your hot inlet, and on your return, it only has one sensor. A temperature sensor on the mixed outlet in the back. The whole thing's controlled through that. So, that temperature sensor sends a reading to the controller. Controller moves your actuator on the 3-port ball valve, and that's moving, that actuator is moving the stem on that 3-quart ball valve, letting in a little less cold, or a little bit more cold, or a little less hot, a little more hot, to hit your desired set point. As far as setting it up, it's very similar to the Intellistation Sr. Program, unlock, and then we put in a factory default code, or the one that the facility has set up. Hit enter, accept the terms, go to settings, or setup, system, and then you have 4 options there. Valve selection, is it a 3/4 or a 1 inch, or the larger diameter is 1.5 inch or 2 inch. And then you've got your mixed set point. On your mixed set point, you've got the touch screen sliding scale to where I can adjust the temperature to whatever I want, or use the arrows to change it 1 degree at a time. Once I've got it dialed in to 120, what I want it set at, I hit accept. I can go back, go to the home screen, and it's going to show me what my mixed temperature is and what my set point is. And then this actuator will move to keep that dialed in, trying to keep it within plus or minus 2 degrees. Also in the programming mode, I'm in setup, in system, I have your high temp alert. If you go into high temp alert, anywhere from 10 to 30 degrees, if it spikes to whatever, say I have it set at 25, if it gets 25 degrees over the set point, this thing will shut down, recalibrate, come back on, and try to balance back in. If that happens 3 times in a row, then that's when it goes into a lockout mode. Except that, there's also a low temp alert for the same thing. If it goes too low, then it'll recalibrate 3 times and go into lockout mode, sound an alarm, and someone's got to come down and figure out what's going wrong with the valve and troubleshoot it from there. After that, we back up. This also has your BAS, which is an integrated feature that comes standard in the controller, BAS compatible and ready to go. After that, you set your time, your toolbox, your monitor, so that you can see what was the highest temperature this valve has reached since we've been in here and set it last, what's the lowest temperature, and so on down the line for these different data points. Once you've got it all set up, ready to go, it also has the sanitization mode, so if you're doing a sanitization for the building, you can go right in to hit sanitization, except pick the temperature and how long. So let's say we wanted to run it for 160 degrees for 30 minutes. We set 160 degrees, 30 minutes, go. It'll raise that temperature up to whatever you have it at, as long as the supply temperature can reach that temperature, and then it'll start that countdown of my 30-minute timer in this case. Once it reaches the end of the 30-minute timer, it'll go right back to the settings that were originally in it. Aside from that, it's just like the Senior. It's scale resistant because that 3/4 ball valve is stainless steel and under constant actuation. It's the plus or minus 2 degrees, very easy setup. Very easy sanitization mode, volatile memory, no battery or anything, it's just a capacitor that powers this whole thing. Your power could be off for a year. When it came back on, the same parameters that you had set for the power outage will still be on it. So for the most part, that's it. That's the Intellistation Jr. in a nutshell.